I think you're right. All right, that's my takeaway from today is get some ski lessons this year. So I'm wearing my Michigan Tech Husky shirt. And you've got a Husky on your background. And so, Hanieh, where's your Husky?
I am the one missing. Just give me a second. I'll get my Husky.
All right, and then we're going to introduce Tim. So Tim, thank you again for being one of our featured speakers. And I'm so pleased to have you here. This is, for those of you who are just joining us now, well, gosh, we have 42 attendees already. All right, where's
There it is. This is Husky.
Hanieh.
I have a bunch
there
of
you go.
cups and everything. Just unfortunately don't have a shirt, but
we're going to send you a t-shirt as a result of your, agreeing to be a co-host.
Thank you.
Oh, wow.
Appreciate that.
Yes, you're going to get one too. You're going to get one too, Tim.
Oh, cool.
All right, so we're going to go ahead and get started and start the recording. So I want to just take an opportunity to welcome all of our viewers here. We're going to be introducing the speaker shortly. My name is Janet Callahan. I'm Dean of the College of Engineering at Michigan Tech. The College of Engineering is one of several colleges, and tonight's featured webinar speaker is the Associate Dean of our new College of Computing, and he's going to be formally introduced in just a moment. So this Husky Bites webinar series was started in a pandemic because we just wanted to have something else to listen to besides the news, to be quite honest. And it's become a lot of fun. It's learned something new in 20 minutes. We've had a few speakers go longer and I don't ever cut them off. And so Tim, you may go longer, it's fine. But I just want to thank the audience. We have a faithful audience who just keeps joining us. And I'm sure we have new people tonight because of the topic area. So this fall, we continued the series and we have included the idea of a co-host. And so Hanieh, I didn't tell you, but your job is if I should fall out, you are now the host and just handle the questions. Sometimes there's technical glitches in the area. And so our co-host this evening is Deilamsalehy, and I probably butchered your name, I apologize. So Hanieh is one of our alumna. She is actually she's Dr. Salehy. She earned her PhD under Tim Haven's mentoring. And I believe she was Dr. Haven's first PhD student. And I think we're going to hear a little bit more about that in a second. Hanieh is now working at Adobe, and we're very, very, very pleased at her career progress, and I'm very, very excited to have her here on the program. Hanieh earned her bachelor's degree in Tehran, and then she had heard about Michigan Tech because of its reputation and came here to earn her PhD. And your PhD is in the field, is it it's electrical engineering, right?
That is correct, yes.
Okay, very good. And so that would have been in the Department of Electrical and Computer Engineering. And so, Hanieh, I'm going to go ahead and turn it over to you to introduce our featured speaker this evening, Dr. Tim Havens. Take it from here.
Thank you, Dr. Callahan. Hi, everyone. Welcome. And our today's speaker is Dr. Timothy Havens. He's the Director of Institute of Computing and Cyber System and Associate Dean of Research at College of Computing, and also William and Jackson Associate Professor. On top of all of that, he was my PhD advisor. I still remember the first day that my first interaction with Dr. Havens. So it was the beginning of the first semester that I had at Michigan Tech. I didn't have an advisor. I was actually talking to people with potential possibility to work with them. I had looked Dr. Havens' profile on Michigan Tech website, and I really, really wanted to work with him. So I scheduled a meeting with him over email. And in my mind, I had practiced like 100 convincing conversation why I would be the best candidate. So on the day of the meeting, I had my resume in my hand. I walked into his office, like he welcomed me. We sat, we had a pleasant conversation about my background and what I'm interested in, why I'm interested in. And he explained to me all his work. And after all of that, I was like, okay, this is the moment. He's going to start asking me all kinds of challenging questions. Be prepared. You got this. And then he looked at me and he was like, do you want to check out my lab? And that was it. He didn't ask me any challenging, but it was just a nice, fluent, pleasant conversation. And then he basically told me where his lab is and I can go check out the lab. And at the time it was called robotics lab. The name has changed now, but at the time it was a robotics lab. Yeah, and that's how my PhD journey started with him. It was not an easy one, but his support and his mentorship definitely made it so much easier. And I am very happy to be here today enjoying his talk, just like the old times that I was in his class. And I hope everybody else also enjoys the talk. With that, I'm going to hand it over to Dr. Havens.
And I'm just going to jump in and acknowledge that this evening's presentation is sponsored by the Minarek family. Dean Adrian Minarek is the Dean of the College of Computing, and we're really grateful for that sponsorship.
Well, thank you to the Minarek family. And thank you, Hanieh, for the wonderful introduction. You know, I have to say that as an educator, the best part of it is like reconnecting with your students after they go out into the world and become a full human being. And it's super fun to see what they're doing and see all their successes and just hear about it. And so seeing your face again is great. It's great to have you here. And it's just an honor to be introduced by you. So I appreciate it. Thank you. So today I'm going to talk about, let me share my screen here. Okay, so you should be able to see this. Warm and fuzzy machine learning. So my area of research has been fuzzy systems and fuzzy logic, which you may have heard of your fuzzy logic, like rice cooker or your washing machine, and that might be the only thing you know about it. I'm not going to really talk too much about it today, but that's where this title came from. And then I will tell you a little bit about what machine learning is. And so when I first started putting together this slide deck, like I looked at this picture and I thought, oh man, yeah, that's probably what campus is going to look like on October 19th when I give my talk. And that's not the case. So this is what campus looks like currently, although this is a little bit of an exaggeration. This is a picture from last year. So we have 3.5 inches of snow. And so, you know, I'm going to get out my Husky Michigan Tech hat here so I can stay warm and keep going. Okay, so I want to tell you a little bit about my journey. Not only do I work at Michigan Tech now as a professor, but I was a student here. So I grew up in Traverse City, Michigan, which is, you know, in this little, the pinky of the mitten, and came up to Michigan Tech in 1994 as an electrical engineering student. And so I did my bachelor's and master's here at Tech. And after I left Michigan Tech, I went to MIT Lincoln Laboratory, which is a federally funded research and development center in Boston, Massachusetts, part of Massachusetts Institute of Technology. I worked there for 5 years, just doing really exciting research on Department of Defense systems, primarily Air Force systems, and airborne laser is what I worked on quite a bit. So you could Google airborne laser and you could find a picture of the 747 jet with a giant laser on the front, which was going to shoot down ballistic missiles. They kind of shelved it. It was a system that didn't quite work, although a lot of great technology came out of it. But after working there, I realized like I really needed that connection to people. I did some teaching when I was a graduate student here at Tech, and really enjoyed the classroom experience, really enjoyed working with students, and thought, oh man, I'd love to get a PhD and work with students. And so at that time, I'd started dating a girl in New York City, and she moved to Missouri during that time and said, I'm going to get a PhD at the University of Missouri in creative writing. And I thought, okay, you know, I got a choice to make. I'm going to go there too. I'm going to get a PhD in not creative writing, but electrical and computer engineering at the University of Missouri. It was a great experience. Later, I'm going to talk a little bit about my advisor there, but you know, PhD advisors are such a vital piece of the experience as a PhD student, and I was really lucky to work with Jim Keller at University of Missouri. After that, I went to Michigan State University as a postdoc, and I had funding from NSF for a couple of years. I finished at the University of Missouri in 2010, which is kind of right in the middle of the downturn, economic downturn, the Great Recession, as they called it. And so the job market was rough. And so I was lucky to to get some funding to work at Michigan State for a couple of years. And then finally, I was able to come back to Michigan Tech as a professor after that. And I've been here ever since. So I run the Prime Lab, which is the Pattern Recognition and Intelligent Machines Engineering Lab. So acronyms, that's actually the most important thing about coming up with a name for whatever you're inventing or your lab or whatever it happens to be. And so usually, you come up with the acronym first and you try to fit words into it. And so that's what I did here. It works. So we do all kinds of things. We do things from immediately deployable things in feature and sensor fusion, which I'll talk a little bit about today, or combining to get together different types of information to make an inference about the world. We do some radar processing, how to produce the best images possible from radars so that you can find things buried under the ground. And then we also dabble in some next generation RF arrays. I had a PhD student who has graduated last year, and he's now at Los Alamos National Lab. And he was working on simultaneous transmit and receive radars, which is radars that both speak and listen at the same time. And that was some really fun work there. So I'm going to talk about the College of Computing next, because this was something that we just formed in 2019. And so we're going to do a poll, because I guess part of the Husky Bytes experience is getting the users to, or the participants to do some interact. So when did Michigan Tech start its computer science program? So apparently there's going to be a poll that's going to come up here. Oh, here it is. Okay.
All right, and so the choices are 1965, 1970, 1980, or 1994. And if you're joining us in the Zoom webinar, you can see people answering questions live. And I know we have lots of people out there on Facebook live stream, so I'm going to kind of read out who's winning. So lots of people are voting for 1970. That's about 36%. And then we have about equal parts almost across the rest. So that's interesting.
Wow, this is like Who Wants to Be a Millionaire?
Yeah, I know.
This is cool. Okay.
I don't know the answer.
Yeah, I'm going to go. The answer, so the audience is correct. The answer is 1970. So just a little history, we started our first Bachelor of Science in Computer Science and Engineering in 1970. We had a BS of Computer Science shortly after there. And in 1980 and 1994, I'm gonna hide this window, we got an MS in Computer Science and a PhD in Computational Sciences and Engineering. But one of the most exciting recent developments is the formation of a full College of Computing. So computer science used to be part of the College of Science and Arts, and applied computing department, which is also part of the College of Computing, was part of the college, the School of Technology. And so in about 2012, about the time I joined the university, you can see those yellow bars on the right, people started talking about, okay, how do we bring this computing that's going on at Michigan Tech, these really exciting things in computing, to the forefront. So there's committees formed, because we love committees as academics, and a lot of talk. There was an alliance formed called the Alliance for Computing and Information and Automation, and then eventually it led to this task force called the Data Revolution and Sensing Task Force, which then turned into the College of Computing. And so now we have a College of Computing at Michigan Tech that started in July 2019. It's been such an exciting year. It's been great to be a part of the formation of this college. And I'm going to talk a little bit about it. And I'm also going to talk about the research arm of the college, the Institute of Computing and Cyber Systems. So this is the College of Computing kind of in one slide. The idea is that we are a college that can interact as the computing core with the rest of the university. So we have our core degree programs, which you see are listed there. And then we have convergence degree programs, which interact with us, such as computer engineering, robotics and mechatronics, human factors, data science, computational science and engineering. And that's the education side on the left. On the right, you see the research activity, and this is where I play my part in the college. Is I direct the Institute of Computing and Cyber Systems, and I'm also the Associate Dean for Research in the college. And so you can see how those fit together. So the ICC, or the Institute of Computing and Cyber Systems, is a research institute at the university. It has about 60 faculty members that contribute from nearly every department at the university. And we do everything from computer engineering, cybersecurity, robotics, to data science and convergence computing, which is just a term for interdisciplinary work, or how can computing help in other fields and work closely together. So just to give a little bit of, put some names, this is the academic structure of the College of Computing. Dr. Minerick is the dean, also the sponsor for today's Husky Bites. Linda Ott leads the Department of Computer Science, and Dan Furman leads the division, or is now, I should have changed that, the Applied Computing Department. And you can see the various degree programs in those two departments. And then we also started a joint degree program between those two departments, BS and cybersecurity, which just started. And then Chuck Wallace is the Associate Dean for Curriculum and Instruction, and then I'm the Associate Dean for Research. And so Chuck and I kind of work together to strategize how we can move forward both the education side, the curriculum and instruction, and then also the research side, which are, of course, overlapping and very related at the college. This is a picture of a bunch of College of Computing students and the faculty. You can see that most of the faculty are over on the right. And then we also emblazoned our college upon the bridge that's between Recce Hall and the library. You can see that up there. It's been a fun ride. So part of my charge in leading the kind of the research element of the college is leading the Institute of Computing and Cyber Systems. And so this is a research institute that exists kind of outside of the college structure at Michigan Tech. And the idea is that we kind of act as a business, in that we have research funding that comes in, and then we reinvest some of that funding back into our members so that we can help them build their research programs. So we bring faculty and students together across campus to talk about computing. We really want to foster interdisciplinary collaborations, which are, merging computing with other disciplines, whether it's in the arts or the sciences, and then create platforms for collaborations across all kinds of fields, and then promote the external visibility of computing in the region and the world. And so you've probably seen blog posts from the ICC on Facebook if you're following Michigan Tech, and this is part of our objectives.
So I'm just going to jump in here. So if anyone has potential research that involves computing where you think there is a possible fit, Tim Havens is a great contact. Do you want to just tell us your email?
Sure, it's thavens, THAVENS at mtu.edu. Yeah, and this is part of what I do just about every day, is figure out how can we build teams to solve problems. So if there's things that you are interested in having us solve for you, or working with us to solve, we'd be happy to talk with you. So the ICC is built around 6 centers. These are sub-centers that each have a director. So cyber physical systems, that's kind of the interaction of computing with the real world. Cybersecurity, how do you keep computing secure? How do you keep from your credit card company from getting hacked? Data systems, or data science, it should be, that's a typo that I keep seeing and haven't corrected. I'm going to correct it next time. So data science is things like I'm going to talk about today: deep learning and big data, artificial intelligence. Human-centered computing, exactly what it sounds like. Scalable architectures and systems. This is kind of like the core of how computers work. And then this is our newest center, is the Computing Education Center. And this has really come to the forefront, especially during this pandemic, where everybody is learning via computers. And so computer education is all of a sudden, it was important before, but it's just really hit the forefront of pertinence. These are my institute directors in each of these centers. Sarah Sun in mechanical engineering. I lead the data science center. Guy Hembroff is in applied computing. Beth Vienot is in cognitive and learning sciences, Soner Onder is in computer science, and then Yu Kai is in applied computing. So you can see it's really a very interdisciplinary set of even the directors of these centers in computing. So now we're to the next poll. I've told you a little bit about the College of Computing and our research arm, the ICC. And so I want to put it back to you and say, how many of MTU College of Computing graduate students find full-time positions after graduation?
All right, and we've got 4 choices: 10%, 50%, 85%, or 95%. And we have one person who thinks that only 10%
Who's the joker?
Gets a job.
They're the one who said, obviously, the answer is 95%, right?
Yes, everybody else that kind of is pretty convinced that you have a high probability of getting a job if you get a degree.
Yes, it's 95%.
Very good.
And this kind of exists across the College of Computing and College of Engineering and the other sciences at Michigan Tech. I mean, scientists and engineers and computing specialists are in super high demand out in the real world, and so it's just a great degree programs. So the next poll is so we know that 95% of people get a job. What's their average starting salary of these graduates?
Aha, so this is the next poll, and their choices are 40,000, basically 53,000, 65,000, or 93,000. And so everybody knows that people earn more than 40,000. And it looks like the winner here is going to be 65,000 as the average guess that people are making, with a few people, 25%, voting toward 93,000.
Well, the people who voted $93,415 are not necessarily wrong, but $65,000 is the answer. We've got a smart audience, but $93,415 is the average starting salary of master's graduates in computer science across the nation. So this is, I didn't have this data point for just us, but we're probably not far off. We're usually pretty close to, if not exceeding national averages. So
that's a very big differential. I'm actually astonished at how big that is.
It is. And I see this in the small pool of graduates that I've worked with, that students who go on to get a master's degree or a PhD are getting significantly higher salaries. And it's just that extra little bit of education, that research experience, that becomes just invaluable to companies. And one thing that I can plug here is that if we have students on this Husky Bites, consider the accelerated master's programs that we have here at Tech, yes, where you spend 1 year after your undergraduate getting a master's degree, and you can see, you basically could pay off your tuition in the first year that you have that jump in salary. So yep, it's just a really, really good investment.
Well, and these accelerated masters allow you to count 6 of your undergraduate credits toward your master's degree. So it saves you some effort and work. And lots of universities have it, but I think it's I agree with you, Tim. All right, teach us something new.
Okay, so I'm going to talk to you about what deep learning is. And so here is a picture of me with some undergraduates that I was working with with a large drone. And we were using these drones in a Michigan Department of Transportation project that we had, developing ways that they could use those to look at transportation infrastructure. And so I'm not going to talk about that right now, but I am going to talk about deep learning versus human learning. And so deep learning is a term we've probably all heard. It's been in the news all over the place. It exists kind of in every tool that you're using on your phone and Facebook. You put a photo up on Facebook and it automatically detects who's in the photo. That's deep learning. And so what is deep learning though? Well, really, deep learning is based on a model of brains, not just the human brain, but brains in particular. And so the brain is just composed of millions of these human neurons, these cells, or just not even necessarily human, but just neurons. And what the dendrites do is they collect the electrical impulses from other neurons, aggregate them in some way in the nucleus of the cell, and then send out a new signal on the axon, which is then connected to other dendrites, and so on and so forth. And that's kind of how your brain sees this presentation, how it interprets what I'm saying. So the artificial neuron is inspired by that. And it's basically built in the same way, in that there's inputs that come into the neuron. Those inputs are summed up, and then there's a function that's applied to those inputs that are summed up, and then those are output to a whole bunch of other neurons. And so the structure mimics that of a real brain. And that's kind of where it ends, though. It's not anything like a real brain. So the difference between deep learning and human learning is that human learning is very adaptable, or even just learning of animals, period. So an animal gets into a new situation, and they can usually adapt to that situation and be okay at it. Deep learning is not that. And so this is kind of the first misconception of machine learning, is that it's smart. It's not. It's just really good at looking at tons and tons of data and coming up with a decent model to get a good estimation from those data. So it can look at billions of pictures, way more than you could look at in your lifetime, process those in order to make an inference of, is that a picture of a cat or is it a picture of a dog? All the important problems of our day. So what does an artificial neural network look like? Well, it's just stringing together a whole bunch of those neurons. So there's inputs that go to one side of the network. Those go through this whole network of neurons, just like a brain. And then finally you have an output. And so typically that output is a classification. Is this a picture of a cat? Is it a picture of an eagle? Is this Tim Havens in the Facebook picture, or is it his mother, Jan? And so now we're on to our last poll is, so given what you've just seen about, kind of how the artificial neural network works, and kind of, see its simplicity, when was it invented? 1918, around World War I, 1940, around World War II, 1958, early 60s, computer revolution, 1971, that's when computers really started to get used. We have a little bit more of a spread on this one.
Yeah, very few people are guessing 1918 though. We've got over 100 people in the audience, and it looks like 1958 is slowly winning here at about 35%.
Okay, and so the 1958ers are correct.
Oh, how about that?
Yeah.
I did wonder how many people are out there looking up the answer. What do you think?
I don't know, they're pretty quick. I don't know, Siri's pretty quick though right now. So Frank Rosenblatt in 1958, at the young age of 30, invented the artificial neural network as we know it these days. And so what you can see him doing here is he actually designed this mathematical structure, which you just saw. And what he was trying to do is say, okay, given that mathematical structure, could it learn to tell the difference between pencil marks on the left side or pencil marks on the right side of these punch cards that you can see being input into the computer there. So Frank Rosenblatt was super smart. He went on to really become a pioneer in this area. And interestingly, though, in the late 1960s, he started to get in a fight with Marvin Minsky at MIT. And so Marvin Minsky was this artificial intelligence pioneer at MIT. And Marvin Minsky kept saying to Frank, Frank thought okay, the artificial neural network is going to solve all our problems. It's going to be like the AI of the future. And really, he's right. He was absolutely right. It just took, 60 years to happen.
It transcended his lifetime.
It transcended. And so they got in a big fight, and Marvin Minsky said, no, this isn't going to work. And so he wrote a book about stringing together artificial neural networks, and the perceptron, as Frank Rosenblatt called it. And Marvin Minsky really ended up to be correct. And unfortunately for Frank Rosenblatt, he didn't really get to see the dawning of the neural network, the first age of neural networks, because he died in 1971 in a sailing accident. And so it's kind of another story of this genius who just died too early and didn't get to see it. But interestingly, the neural networks became super popular, kind of underneath Marvin Minsky, and then they totally the fad ended. The age of hype ended on neural networks in the 1980s, and everybody said, no way, these are bad ideas, they don't work. Well, the funny part is like the early 2000s, late 90s, early 2000s, deep learning came around, resurgence of basically the same thing, and now deep learning is everywhere, and it's driving a lot of the computer industry, the consumer industry especially. And so the IEEE has its biggest award in this area of neural networks is the Frank Rosenblatt Award. So I have to give a little bit of a plug now. We're having an ICC distinguished lecture at the end of the month. And so if you're interested in this, go to the blog post at blogs.mtu.edu/ICC with Jim Keller, who is a Curator's Distinguished Professor Emeritus at the University of Missouri. And so he won this year's Frank Rosenblatt Award for fundamental work on fuzzy pattern recognition, fuzzy clustering, and fuzzy technologies in computer vision. And he is also my PhD advisor. So I'm just super proud of Jim for the work that he did. And he was just an excellent model of how to be a good PhD advisor, which if I can even approach that at 50%, like I'll feel as though I'm succeeding. So thanks, Jim. Hopefully you're out there. Talk to you soon. Okay, deep networks. So now artificial networks turned into this thing that in the early 2000s, all of a sudden was everywhere. And it's because of Jan LeCun and Jeff Hinton inventing these deep networks. And the idea is they just strung together a whole bunch of artificial neural networks. And honestly, that's all it is. It's just, it's deep because you have a whole bunch of neural networks all strung together. And so this is the task that I teach all my students first in neural networks is it's called the MNIST data set. And what it is it was zip code numbers of postal envelopes. And so we took these, and I'm trying to watch the Q&A. Oh, we have John Soyring saying Warren McCullough and Walter Pitts at the University of Chicago as the creators of the neural network in 1944. So interesting. We'll have to look at that later.
Well, and we'll, yeah, we will take questions at the end. But okay. I just sure hope you explain what fuzzy is at some point.
I'll get to it. Okay. Yeah. So
it's a new word for me.
Essentially what happens with these neural networks is the pixels of this image get passed in, and then there's a whole bunch of filters that get applied to this image over and over in different ways. And so you can see, this image gets turned into a whole bunch of new images. So some of these are looking at certain types of edges. For example, a 7, as we know, is a vertical edge or a horizontal edge with a diagonal edge. Then those are passed to additional filters, and you have new images, and then finally they just go through to the end until you have a classification of the numbers 0 to 9. Interestingly, with these images, you can get about 99.99% accuracy with a very, very simple deep network that you could train in the matter of seconds on a normal gaming computer. So something that your teenager probably has in order to play, I don't know what a game is, Battlefield or. So really powerful systems. And so how are neural networks trained? Well, this is the crux of networks, is that you need tons of data. And so there's, in this case, the training data for the MNIST network is 60,000 numbers from zip codes on mail. So you can see just some examples of those there. You pass those into the network, and then you look at what the output is. So you just start the network somehow. You give it an initialization. Usually it's just a random initialization. And you say, okay, how good is the network at processing these numbers? And then you compute the error between what the network is spitting out and what the true label is. And then you just adjust the network to fix that error. Now there's a lot of math behind that. There's a lot of calculus, but honestly, it's pretty straightforward. And how these are trained once you really dig into it. And then you just rinse and repeat. You just keep doing this until the network truly learns how to recognize a 5 versus a 4 versus a 6. So now I'm going to get to an application that I've worked in for a while now that we kind of see like what a neural network looks like. And that's find the hazards. So one of the big issues that our military has overseas is things that are buried in the road that could possibly harm them. So I'm showing you an image. This is a test lane that we use, and obviously there's a little red circle there, so you can see where the hazard is. But if that red circle didn't exist, which the red circle doesn't truly exist in the test lane, it would be very, very difficult to see where that hazard is. And so this is where we're applying this machine learning. And so the system that we work with is this US Army dual band radar. It has a LiDAR, which is a laser radar. So it just sends out lasers, counts how long it takes for those lasers to bounce off stuff, and then can measure the distance in each of those directions. It has inertial sensors and GPS, much like an aircraft, and how it detects where it is in the world. It has a high frequency radar, so they can see kind of what the surface of the Earth looks like. It has visual and thermal cameras, and it has a low frequency radar because just like, you know, if you've ever lived in an apartment and you have a neighbor that listens to like music really loud, what do you hear? You hear the bass. And so those low frequencies allow you to look inside the Earth because they penetrate through the Earth and allow you to see things that may be buried. And then there's different polarizations of that radar, much like you would have like with your polarized sunglasses in order to look for fish in the water. And so the Army was asking the question of how many sensors do we really need? And so we have the low frequency radar, which produces images like this. And so I've kind of shown where the targets are, but you can see there's a lot of things in that image that look like targets. And then you have the thermal cameras, the mid-wave and the long wave. That's just two different frequencies of thermal imagery. And so you can see in each of these images that there was something that was buried in the ground there. And the way that the sun heats that area of the ground is different. So you can see it in the thermal imagery. But that also changes throughout the day. So then we also have the laser radar, which looks at the world to determine, okay, what does the surface of the world look like? And so here you can see what like a bush looks like as opposed to, say, something that is not a bush. So then you could determine, okay, is that radar return really coming from a hazard, or is it coming from something like a bush? And so this is what the innovation that we have is we're combining together all these sensors on this vehicle. And then through years of research, we've developed different ways of processing those such that we can indicate where to dig in the ground for an object. And so we're using, I have PhD student Adam Webb, who's looked at dual regularized imaging. He's working on his PhD student right now. Another PhD student who graduated about the same time as Hanieh is Tony Pinar, and he did some ensemble filtering approaches and deep network fusion approaches. And finally, from all these sensors combined together, we can say, okay, that red circle is where we dig. And so we've really enhanced the ability of the Army to indicate hazards in the road so that they don't drive over these things. So that's kind of my research in a nutshell. But I wanted to kind of take a step back and say, okay, if you're interested in deep learning, what are ways that I can learn more about it? The AlphaGo is a great movie about deep learning. Hold on, I have a cat who's making a lot of noise. This movie was made by a filmmaker who did a lot of filmmaking for NFL films, so it kind of has that sports feel, so it's really exciting about this really kind of dry topic. So I really recommend that. But what's crazy about AlphaGo is this algorithm beat the world's best Go player without very much training. And recently they've developed an algorithm that learned from no data at all. They call it AlphaGo 0, and it is even better than AlphaGo. So it's a fascinating AI story. But there's other fun with deep networks that you can find out there. So up here on the left, these, if you go to thisxdoesnotexist.com, there's a whole bunch of examples of this, but this person does not exist. That person was generated by a deep network, and they do not exist. They're not real. That cat does not exist. It's not real. And the lower left, I'm showing an image of this thing where you draw a picture with these lines, and then it'll take that picture and make a cat out of it. You can see it's kind of strange looking, but it's a neural network approach. These are called generative networks. Another generative network approach is this generating Super Mario Brothers levels. And then this, I didn't know this existed until today, and I just found this. Google has this thing where you go and you play a game, and it says like, okay, draw a horse. And then it uses a neural network to, you have 30 seconds to draw a horse. And if you can draw it good enough for the neural network to recognize it, then you win. And so these were the 6 things that I drew. So you can see it recognized a horse from just that. Recognized that paintbrush looks good. But that's all it took to recognize a lion. That toaster is terrible. That's all it took for it to recognize a dog. And finally, I mean, it recognized that beach like lickety split. So so go out to quickdraw with google.com. It's really cool. It's just another example of how neural networks work. So that's actually the end of my prepared remarks. I know, Dean Callahan, you really want to talk about the fuzzy stuff. So maybe if people stick around and there's questions, I can talk more about the fuzzy stuff.
So thank you, Tim. Thank you for kind of, framing this by describing the College of Computing and its new structure and leadership and research opportunities. Wait, put the cats back up.
Oh, okay, sure.
So Tim has 2 cats. Tim is one of our characters. I think all our professors and faculty are characters, but Tim is especially a character because he never hesitates to show beautiful pictures of his cats and to play live music and to do all kinds of different things. One of them was being
kind of naughty during my presentation.
Well, there's no such thing as a naughty cat. It's just part of their, their neural framework.
Right.
Those are beautiful pictures. All right, so I'm going to go ahead and exit your share screen. I'm going to share my screen because I want to make sure I queue up the slides for next week. I forgot to do the preview slides, but that's okay. Start loading up your questions in the Q&A, which is one of the buttons down at the bottom of your Zoom webinar. So I'm going to present my slides. And so if you're joined us late, I just kind of want to thank the Minarek family again. So Dean Adrian Minarek is the Dean of the College of Computing, which is the newest college we have here. Wait, that may not be true. Well, anyway, I think it's the only College of Computing in the state of Michigan, I believe. Is that true, Tim?
Yes.
I think that's still true, yeah. And so anyway, thank you, the Minarek family, for your sponsorship. We were unable to actually Facebook live stream this. This is the first one we've been unable to, but this video is, all our videos, our Zoom videos are saved. They are annotated. So if you couldn't understand the words or the speaker, they're captioned, and they are posted on the Michigan Tech College of Engineering website under Husky Bytes. I didn't ask who's here today. I apologize. And we just heard Tim Havens speak. And so you guys are all loading in your Q&A and the questions and answers. But I would like to give a preview for next week's speaker, which is Dr. Paul Bergstrom, who is a professor in the Department of Electrical and Computer Engineering. He's also an affiliated professor with the Department of Materials Science and Engineering. There's going to be a co-host who is one of our ECE graduates from 2004, who works at PsiQuantum, and the co-host name is Thomas Wallner. So these Husky Bytes webinars are every Monday night. Our last one of the season is, I believe, December 6th, 7th, or 8th. we are going, including Thanksgiving week, we've got a full lineup. We start with chitter chatter at about 5:45. Feel free to join us. The weather outside, Tim did mention this, it has already snowed 3.5 inches this year, although there's nothing really left on the ground when I look outside the window. So it's been snowing a little bit and then kind of melting, but it's awfully exciting. It's not even Halloween and we got a little bit of snow. It's fun. So that is next week's speaker. And so now we're going to move to Q&A, and I'm going to stop sharing my screen. Oh, I need to mention one more thing. If anyone would like to sponsor a webinar, all you need to do is send an email to engineering@mtu.edu. Any level of support is appreciated. 100% of the proceeds go in direct support of the General Student Scholarship Fund. And so the way to ask questions is to go into the Q&A and just type your question in. And you can make a comment. You can say hello if you're a graduate and you just want to say hello to Tim, whatever you want to do. So, so Hanieh, feel free to help me with the Q&A. So you can pick a question to answer and make a comment, whatever you would like to do.
Sure. I actually see a question here that was, my name was mentioned. It says, Professor Havens and Hanieh, what are the best undergraduate majors to study machine learning and AI? What are the different applications and industries where they are used? So I'm going to leave the first part to Dr. Havens to answer later because he's going to have better guidance on that. For the second part of the question, I can tell them about my journey. Before I graduate, actually before I defended my PhD defense, I started an internship at Ford Autonomous Vehicle Research Center. And then after graduation, I joined Microsoft, and from there, I joined Adobe Research. I can tell you that I've been in many teams, and the whole time I was working on machine learning in many, many different applications. So I started at Ford with working on autonomous vehicle research. Then I joined Microsoft for a project that I cannot talk about it, but I can just tell you that it was an application of like 3D imaging and virtual reality and mixed reality that, again, the same fundamentals, the same concepts apply. Then I joined the team. If you have ever heard of like Microsoft Stream, for example, it's under Office. It's a new product. Some of the people might not have seen it. It's basically similar to YouTube. It's YouTube for enterprise. So I was working with video, which sounds like a completely different area than like something like autonomous vehicle. Again, a lot of machine learning same concepts were applied there. And now that I work at Adobe, I work on similar stuff. I mostly work on NLP, which is natural language processing, which is some things like what you see when you talk to, for example, if I can say her name, Alexa. She's gonna respond now. Or you can talk to like your basically virtual assistant, the way that the assistant understands human being talking, processes it, and can answer to that. So there is many applications in many different fields. I can tell you that machine learning and AI is very hot. Everybody is trying to use it one way or another.
Well, and for those of you who joined us late, Hanieh is Dr. Tim Havens' first PhD graduate, and she's joining us as co-host because we are really featuring some of our graduates as part of the Husky Bites kind of experience. And so if anybody has any more questions about career opportunities, Hanieh should be able to kind of answer some of them. So Tim, do you want to take the first half of that question?
Yeah. Well, if you want to become a machine learning scientist, math, computer science, computer engineering, electrical engineering would probably be your top choices. My degrees are all in electrical and computer engineering. So interestingly, I am a professor of computer science at this point and have no degrees in computer science, but just when you get to the PhD level, your research area really kind of more defines what you can teach and the types of research that you do. So it's totally appropriate. But those would be the places where I would start. And so on the engineering side, you're going to be more of a practitioner. of machine learning. How can you apply machine learning, say in sensing systems, building sensing systems, like that big Humvee that you saw. Where on the computer science and math side, maybe it's more of a theorist of how machine learning works and how to develop new machine learning methods. But really, as far as you won't really do much machine learning until you get to the graduate level. So that's where that master's degree really, that's why it's so valuable, is because you really start to do things that are on the state-of-the-art forefront of fields. And so you become that much more valuable to companies.
All right, Hanieh, I'm putting you on the spot to help be a co-host here. So what question should we tackle next?
Sure, I'm gonna go with the ones that directly mention me first, and then if there's time, we'll go with the other ones. So I'm gonna answer Toby, who has asked a question for Hanieh. How do you use machine learning in your job at Adobe? So we are a research team, but we are actually working on what we call it a bigger, bolder project. So this is something that we hope eventually becomes a product of Adobe. It is at this point like more related to video. There are multiple teams at Adobe working on this product. The largest team is a machine learning team, which I am a part of. So what we do is that we take the video and we try to process it in different ways. Some people work on the images, some people work on the audio part, some people, which is mostly me, I am leading the work that is being done on NLP, as I mentioned before. So we work on the transcript. The whole idea is to make the life of the user easier by automating a lot of process. For example, I can't talk about this specific product, but I can talk about something that is like out there. If you look at YouTube, there is so many features for you. You can search in YouTube for something and it will take you not just to the video, to the specific section of the video that is talking about the subject of that you have been searching for. We are doing something similar with that. Or you can automatically have a whole transcript summarized without any human manipulation at all. There is a ton out there. Dr. Havens mentioned a bunch of like examples with the images to figure out if it's a cat or a dog, or just detect the face of the speaker in that video. Take the presentation, figure out what topics they're talking about. Many, many different applications. These are a bunch that I am involved working with.
Well, and so this question from John, one of our alumni, and Tim, maybe this is a question for you. Would you please comment on what Michigan Tech is doing with respect to ethical use of AI and machine learning?
Yeah, that's a really great question, and certainly is something that I think many people have heard about in the news with regard to machine learning. And Elon Musk and OpenAI have come out kind of saying, "Oh, artificial intelligence needs to be really worried about and could become a problem." And of course, any technology can become a problem and be used for nefarious purposes. Certainly, more technologies, or some technologies, are more dangerous because of their capabilities. And so ethics is a big part of our education here. So computer science undergrads are required to take an ethics course. Our graduate students are required to take an ethics course. Ethics is one of the topics that I've adopted in the machine learning class that I teach at the graduate level. So they have to do a writing assignment on, what do you consider a possible ethical problem with machine learning? And then we look at some of the papers on ethical problems in machine learning, particularly like racial and gender bias in machine learning algorithms. So employers and like insurance agents and insurance companies and things like this have started to use machine learning to kind of screen applicants. And so can you take the applicant data and determine like whether this person is going to be a good employee? The problem is that when you feed in historical applicant data where the only applicant or the only great employees that you've had were all male, because that's the only people that worked at your company historically, then you're biased. And so then the machine learning automatically learns, well, female applicants must not be good applicants. It's what the data suggests. And so there's a lot of research in how you can avoid that type of bias in machine learning. And it's about, understanding the data and understanding how those algorithms learn. So yeah, this is an important and big topic, and should be in nearly every science.
All right, so I'm going to pick the next question to be answered, and then Hanieh, maybe you can pick up the one after that. So this question's from Darwin, who asks, what is the primary challenge to staying current on cybersecurity threats?
That's a really good question. The cybersecurity field is something that's somewhat of a mystery to me. It's this field that doesn't really have like this fundamental underbelly. I mean, it's something that grew out of necessity, like many things, rather than growing out of like the fundamentals, like fundamental math. If you think about even machine learning kind of grew out of statistics and probability and mathematics. But cybersecurity is this need of saying, hey, we need to keep our computer systems secure. How do we do that? And unfortunately, what it really is thinking is like, how do we win this battle between people that are nefarious and want to steal information or bring down your systems or make nefarious gains? How do we stop that? And so it's always going to be kind of this ever-present battle between people that want to do wrong and people that want to prevent that. So I think that's a really good question. There's certainly a lot of strides that are being made. Here we run a summer program for high school students in cybersecurity so that they can learn about cybersecurity principles, learn about different types of attack, how to keep your system secure, how do you start to generalize some of these problems. We do that for high school and middle school educators as well, so that they can learn how to teach it in their classes. And then this year, myself and 3 other professors, Laura Brown, Yu Kai, and Andrew Barnard, who he runs the Great Lakes Research Center, we got a grant from the Office of Naval Research to develop a program for ROTC students, so ROTC, Army and Air Force students, so that we could teach them about the principles of cybersecurity and the things that are kind of ancillary to cybersecurity, things like machine learning. And then we're working with them for a year. Each of these students get paid, I think it's like $18.50 an hour to be part of this program. It's great. And then the idea is that then we can, they can go into the cyber command in the military to help keep our systems safe and keep our power grid on and all that. I hope that answered the question.
I think so. So Hanieh, do you want to? We have 15 open questions, so I'm trying to alternate between who's answering what. And this is something maybe, Hanieh, you can comment on. Hello, I'm a fall 2020 grad student in electrical and computer engineering. I'm really excited to learn about deep learning and dive deep into it. How would you advise to go further in the field? I'm interested in doing projects as well. How can I get involved in doing some projects?
So I think it was mentioned that it doesn't have a name. So this person was a fall 2020 grad student. So for me, what helped me was the graduate program that I did at Michigan Tech, because I was hands-on on projects, and I also took a few classes that helped me a lot to learn the basics of and the fundamentals of machine learning. So one suggestion, this person already has like graduated. I don't know what degree they had, so it's hard to comment on that. But if you have the time and opportunity, I think maybe doing like a degree, even if you don't have much time, maybe that accelerated master degree that you mentioned is a good option in my opinion, because it makes you get organized, do the homework, study, take exams, and actually learn. If you don't have that option, there are many courses that you can take or use the ones that are free. I think that might be a good start, to start with something like a deep learning course or like a machine learning course, and go from there, see what projects you're interested in, and maybe go to somewhere like Kaggle and you can start with projects. But I think the best option to basically register in a program.
Well, and if you're currently a graduate student already, you should do what Hanieh did, which was she actually went out and sent an email to Dr. Tim Havens and said, I'd like to really join your research group. And she was explaining that in the preview, and you might replay that story. So be your own advocate as you're looking for research projects. Be willing to do something for free to show your worth. And perhaps the professor may pick you up on a funded proposal if they're able to. Tim, do you have anything to add to that?
Yeah, Coursera and there's another one. It's like Data Camp have really good courses online. But honestly, I think that in deep learning, it's somewhat like cybersecurity. It's a lot of craft as much as it is science. So the only way you get good at a craft is by doing it. And so just starting, it's like writing a paper. You just got to start writing. You may not know what the words are that you want to write. You may not know what the program elements that you need to put together, but you just start. Search for some tutorials. I think if you did a Google search for MNIST deep learning tutorial, MNIST, you would find something that's fairly easy to go through. I even have some videos that I've done for the graduate student government where I led them through a deep learning exercise. I think you can probably find those. Maybe we can find that link and publish them. But just kind of the more you do it, and the more that you have that intellectual curiosity to figure out, okay, what's next? What can I do? What can I do with my webcam? Or here, let me just show you. This is This is an Intel RealSense sensor. So this is a 3D camera, and I actually have my other computer booted up. I could do a demo maybe if we still have people later. This is like $100, and then you have a camera that takes an image of the world that's in 3D. So with something like this, you can really start to do like interesting robotics problems and interesting like recognition problems in the real world with something very, very cheap. And you could buy an NVIDIA Jetson Xavier NX for $300, which is a small little computer that is about this size. And then you have essentially a high quality sensing system for a robot. Another sensor this is the Intel RealSense LiDAR. So this is a laser sensor that senses the world. And this costs, I think it's $300. It's inexpensive. I mean, these things have really come down in cost. So you can start to do these things in your home, like, developing a new thermostat program. You could do that with an Arduino or an NVIDIA Jetson. So the tools are there. It's just a matter of you have to find that time and that curiosity to make it, the thing that you're really interested in.
All right, and so this is from one of our faculty members here. Are there classes in machine learning for non-scientists?
No, there aren't yet. And I know who answered that. I know who asked that question, because I think Jennifer and I have had this discussion, and really many discussions surrounding it. That's a great idea, and is something that we absolutely should do. I wish that I had the time to do it myself. I think it would be great to teach people about machine learning and give people just the tools, not necessarily make them theorists or developers or designers, but just here's a tool, here's how you use that tool, and go off and solve a problem now with it. And it's a good idea that doesn't exist yet.
All right, and so this next question is from an attendee who saw your picture of the drones, and they want to know, how do you use drones in AI and machine learning?
So drones are really great platforms for carrying sensors where you couldn't carry them before. So, for example, we have a project that we're doing with a security agency. And they want to look at, okay, how can you train these algorithms to detect objects if you don't have much data? So let's say that we only have a few pictures of an object and we want to be able to detect that. Well, they're very interested in overhead detection. So things that are in the air looking down. And in the past, we would have had to pay somebody a lot of money to fly a plane around with a camera to take pictures of things overhead. A lot of money. You know, we're talking about thousands of dollars. Now we can go out and buy a $500 drone, and we can fly it all day and carry around these, these little tiny sensors and get as much data as we need. So they've really become like excellent tools for taking pictures of things from viewpoints that you wouldn't have access before. I mean, you can't fly a plane that low, so you can't get that close to things. And obviously, they're finding use in so many other areas too, at the Amazon delivery systems and all of that as well.
All right, so this next question is from me to Hanieh, and I know I'm jumping ahead of some of the other questions, but and so what year did you earn your PhD here? Because I know you've worked at 2 major companies since then, and secondly, what's the most outstanding feature of your education here at Michigan Tech, in your opinion?
Yes, so the year that I earned my PhD was 2017. I started in 2012. I graduated in 2017, and for 1 semester, I was doing an internship. I wasn't at, 2017, I wasn't at Michigan Tech really. At the same time, I was doing an internship. I think that the thing that I want to point as a feature is that I was amazed how my PhD program actually prepared me for my job, because you always hear that, you study, you take courses, you do research. When you go to industry, it's a whole different world. You're not going to use that at all. And that was partially my mindset, but I exactly got my internship and my job because of the courses that I took during my PhD and because of my research that I did during my PhD. So when I first interviewed at Microsoft, after the interview, my manager at the time was like, what you have done and your background is exactly what we need. And that was exactly what they hired me, because of the specific project, because of the specific knowledge that I had. That was the only reason that they hired me. They had many applicants, and they got me because of that. So I think the right way is just to find out what interests you, work on that. And there is definitely work outside there in any area of machine learning that people choose. There is many applications. People just have to find out what they like and just stick to that.
No, that's really helpful. So Tim, there's a lot of people loving your cats. I'm just saying in the chat and everything. So the next question is there any machine learning built into devices, or is it all kind of on the web?
I'm going to take that one too. Yes, all your phones, they definitely have machine learning built in them. All your tablets, unless you bought them 30 years ago. But pretty much all your smart devices have not just one, but several machine learning algorithms built in them.
Yes, typically in the camera. So for example, if you're an iPhone user, the portrait mode that you probably love because it takes beautiful pictures of your face, what it is really doing is it's detecting what are the pixels of the picture that are you, and then blurring everything out behind you.
Interesting. Well, and I've got my smartphone set to with my face as my security, and it's just totally befuddled by the mask though. The mask is I have no idea who you are. You are not. You got to type in the number. So I I think the mask is the ultimate, misidentifier. So this next question is there any group at Michigan Tech working on hardware level security?
That's a good question. I don't know if the answer to that directly. I'd have to get back
maybe direct them to electrical and computer engineering, or
Well, it could be either in computer science or electrical computer engineering, because there's parts of computer science and electrical and computer engineering that are really overlapped. For example, like the research that Soner Onder is doing in computer architectures and developing computer architectures for purposes, making them faster, making them more highly parallel. And I know that Chewy Chen in electrical engineering has been doing some cybersecurity research for power grid, and I think that there's some hardware implications of that. One of our old faculty members, Zhou Feng, who's now at Stevens Institute of Technology, was doing some things with machine learning on FPGAs, which is a type of chip. So there's certainly a lot out there, and I think some of our new faculty members have interested in this as well, although I wouldn't be able to conjure them specifically yet. It's still a little early for me to know.
So this next is sort of a comment question from Paul, who agrees that Michigan Tech is an outstanding university, and is kind of pointing out that we're sort of a Midwestern secret, sort of, is the greater world starting to attend us? And so my answer is, well, we have Hanieh here, who came to us from Tehran, right? So she had heard of the fame and fortune of Michigan Tech and how well it kind of equipped its graduates for outstanding careers. And so, but we would like your help. Everybody who's out there listening, please help and be our advocate. You can help us by promoting the Husky Bites episodes, by liking us on Facebook, by doing all kinds of social media things. Please, this helps spread the good news. And, these are, you can tune into the seminars that you're interested in, or you can tune into them all. We have like a devoted attendees of about 50. So you can help us by telling the special story of this incredibly strong, technologically focused university. So thank you for that point, Paul. All right, so the next question is there any way to use machine learning to help the environment? For instance, to help make smarter use of plastics, or forecast and help prevent national hazards like wildfires?
Absolutely. I think the beauty of machine learning is that it takes data in so many different forms and returns inferences or predictions about, so you can predict things. So for example, in weather, this is used quite a bit to predict, for example, rain. I'm sure, I don't know how many of you have like the Dark Sky app on your phone for weather. I think it's a phenomenal app. Or Carrot, it's basically the same thing. It has this little rain predictor where, depending on where you are, your GPS location, it'll tell you in the next half hour, the probability of getting rain or how much rain. That's totally machine learning based. So it's taking in sensor inputs and radar from that to determine, like, okay, where you are specifically, when is the rain going to hit? And it's usually pretty accurate. But you can think about like hurricane forecasting. I worked with the University of Melbourne in Australia for a few years, where we were using machine learning on sensors on the Great Barrier Reef to try to predict the impact on the reef from weather systems. And so if you can, start to learn about the changing weather systems due to climate change and how they're affecting the reef, you can start to make inferences and connections between what we can do to perhaps help. And so there's 1,000,001 applications for helping the environment, addressing climate change, energy, all kinds of things.
Well, and this is a comment from John. It was kind of based upon I think when you did the slide on the earning salaries, and the earning salaries for BS in computer science was 65 and the master's was 93K, that's a big bump. And so John points out a master's, an MS degree is required now for most entry-level positions, which I did not know. So this is for the domain of computer science, I believe. Very interesting.
And it opens up a whole new type of position. Without that master's degree, you're not going to be working in like development or design or research or kind of, at that cutting edge of whatever the company is doing. You're probably going to be, fixing things or implementing existing plans, plans that the master's degree holders are making. So.
This is another comment from John. Some credit, and you mentioned this earlier, is given to Warren McCullough and Walter Pitts at the University of Chicago as the creators in 1944 of neural network. So we have about 7 minutes left. I've declared a hard stop to Husky Bites at 7:15. And so I'm going to cherry pick some questions, and I'm cherry picking one from a future student, Ellie, who asked the question that I wanted to know, which is, why is it called fuzzy learning? And I would love to know the answer to that as well.
That's a good question. And I'll admit that I came up with the title of this talk before I actually made the talk, which is completely backwards, but you do what you can. So a lot of my research is based on fuzzy logic and fuzzy systems. My advisor, who you saw the picture of, was one of the pioneers in fuzzy sets and fuzzy systems, especially with regard to like artificial neural networks and pattern recognition and computer vision. And fuzzy sets are just a different way of representing uncertainty. So probability, it represents a binary thing that happens. So you either roll a 1 or you roll a 6, or you're either heads or you're either tails, but there's no mixed state, unless the die is strange. So fuzzy uncertainty represents mixed states, which usually ends up to be a better understanding of uncertainty. For example, like, if you mixed water and beer together, it's not water or beer anymore. It's kind of got like half membership in water and half membership in beer. I guess it's like Bud Light. So fuzzy is just a different way of mathematically representing uncertainty. And we've used it a lot in machine learning by adapting that mathematical model into the data and the decisions themselves and the way that those decisions are being judged for their errors. And so when you can represent mixed state errors, then often you can get a better decision because it makes more sense to a human. So you can start to represent uncertainty in the system. So a neural network could respond as saying, well, I think it's a cat. I think it's a cat or a dog, so you can have these mixed states. And so a lot of the papers that I've been writing in the last few years have been using this mathematical formulation called the fuzzy integral, which I'm sure to a lot of students sounds just absolutely horrendous because, derivatives are easy, right? It's integrals that are the ones that are hard. But it's great because it allows us to kind of do a very nonlinear representation of how decision making happens. And so I have a whole talk that I give on that where I relate it to like how a trivia team works at the bar. So that's why it's called fuzzy learning.
No, and there's actually a question that your response leads into, which is from Robert, who asks, do your machine learning models produce confidence estimates to allow the user to take further action if the result is unclear, so that you don't treat a 51-49% result as a 90-10 result? Is there research into human-computer interfaces and how to accurately convey the results from the machine learning models?
That's an excellent question, Robert. And it sounds like you'd be a really good graduate student in this area, because that is kind of where machine learning is right now. Those are the kinds of things that I was talking to my graduate students this morning about. How do we develop new algorithms that can spit out that uncertainty estimate and also make it meaningful and accurate, make sure that it's correct. And so one of the things that we're working on a project right now is, can you mimic human behavior with deep networks? So could you train a deep network that makes decisions that are similar to human decisions? And so this is of interest in many areas. And in this case, they want to know, like, could this human see this thing in this image? And so we test a bunch of humans. And then the idea is, okay, can we train now a deep network that can mimic the humans and then use that deep network on billions of images, which we couldn't test with all these humans? And so a big part of that is uncertainty, because humans, by the way they make decisions, we're really good with uncertainty. We might look at something and say, yeah, I think that's a truck. But then you get more evidence and say, yeah, you know, I think I saw a truck back there and now I know it's a truck. And so that's where that uncertainty becomes really important. Is like if you propagate that through and keep those uncertain estimates, then you can often make better overall estimates.
I feel terrible. There's so many more questions and we're hitting our hard stop hour. So I guess I want to combine the two questions into one. These are both directed. Well, I actually think I'm going to kind of create a hybrid question. So it's related to the intersection of hobbies and creative activities and endeavors and your field. And so, Tim, maybe you could comment on the intersection of music with your interests, and Hanieh, I know you have outside interests as well. I'm firmly convinced that if we don't nurture our creative sides, we're not going to be effective at work. And so doing these things is not a waste of time, it's actually an investment. And so maybe each of you could comment on that, starting with Tim.
Sure. Well, I'm gonna do the big reveal here. Let's see. This is what my office looks like. So you can see, like, you know, and over here is the wall of bases. And so, you know, the environment that I create for myself it reflects me. So but this computer back here is my machine learning computer. You know, this is running all the machine learning models, and that's why it has the fancy lights. And it's so important for me to have that creative outlet. And I think to be creative in especially very technical work, science, engineering, computer science, whatever it is that your flavor is, it takes an escape from that as well. You have to pull away from that work in order to allow your brain to fill a different space so that when you come back to it, you're looking at it differently. And so music for me is that. And what I love about music is that to be a good musician, you can't be up there thinking about math while you're playing the bass or playing the piano. I mean, it's just not going to work. You're not going to be a good musician. You need to like hyper focus on what you're doing and get into it. That's why that's why I see musicians, they're just like la la land. It's because you have to. And so it's like two dichotomies, but very similar too, because you kind of have to do the same thing to be a great researcher, is like really get into your stuff and think about it a lot. So, and for me, like music, I was always a musician. I wasn't always an electrical engineer. When I was an undergrad at Tech, I was kind of having a fallout with electrical engineering and really struggling and saying, oh, do I really want to do this? And in my junior year, I took a signal processing course, and we started talking about waves and how waves interact and mathematical representations of waves. And all of a sudden, it just made sense to me, because as a musician, I already had this intuition of how all that worked from a musical standpoint. And so I all of a sudden got reinvigorated about, you know, my field that I was kind of having this fallout with. And so it's the same thing, you know, kind of on a day-to-day thing. You're going to have plateaus and lulls, and you're going to hate it, and so you got to get away from it then. And so if you engineer that into your schedule and into your life, then you can kind of keep things rolling.
Well, and Hanieh, maybe some closing remarks. I know that you do active outdoor things, and I think these have the same function.
Yes, exactly. I feel like I had a similar experience when I started working in industry. At first, I thought like the way to do it is just work 5 days a week, and then on the weekends also work. But then I started to feel like, okay, maybe I had a fallout with my job as well. And then I started to take my weekends, go out. For me, outdoor activities are like very refreshing. So I started to go on hikes, mountains and stuff. And then I learned that, okay, I'm more productive during the week now. And I'm also started to like the field a lot more now. I like my job a lot more. And I think it is necessary, as Dr. Havens mentioned, you have to take a break because it is a very brain consuming activity. Like it's not easy. You need to think all the time, and you're going to like it as long as you take a break from it.
Well, and this is just truly excellent advice. There's a whole bunch of proven studies behind what you both said, but it's nice to hear it from, from your own person's story. And so all of us out there working, we should take the time to nurture our souls and to, get outdoors and do some exercise and to play with our cats. You can see the cats on your keyboard. Well, so Tim Havens, Hanieh, Dr. Hanieh, Salehy, who earned her PhD with Tim Havens. I want to thank you both personally for being our co-host and featured speaker on Husky Bites. I want to give a plug again next week. It will be Dr. Paul Bergstrom from the Department of Electrical and Computer Engineering. If anyone would like to send me any messages, my email is just callahan@mtu.edu. If anyone would like to reach Tim, his email is THAVENS, thavens@mtu.edu. And if anybody wants to reach through Hanieh, just send him an email and he'll connect you somehow. And so thank you both. Thank you, Sue, for recording, and thank you, participants. And I hope you have a good evening and stay safe.
Thank you. Bye.
Thank you. Bye.